All right, today it's all about factoring, so let's go back to the very beginning. A lot of people look at something like this and say, well, how am I supposed to factor that? You've gotten so far past it that you forget that you can factor out just simple things. Like what would go into both of those? 2. Factor it. 2 comes out. What you got left? And if this was equal to 0, do you get there to only be one answer? And the answer is what? Put in what and you get 0? 25. There's only one answer and it's 25. And that means that is, think about it, the y-intercept is where x is 0. The x-intercept is where y is 0. So when I put in a 25 here, I'm finding an x-intercept. That's also, it's got 4 names. The x-intercept, the roots, the 0, because it makes the equation equal 0, and the solution. All right, cool. So that was the easiest kind. How about the medium kind? 2x squared plus 4x. Everybody factor that. Two x comes out. Dice of destiny. Roll 1, person 1. Ooh, that only comes up 1 out of 36 times. That's you. 2x. Excellent. And then, are there 2 answers to this one? Yes, there are. Because that could be negative 2, and that would make it equal 0. Or that could be what? 0. Now, did either of those involve square roots of negatives? No. So those are normal roots. That means if you made a picture of this, that it would hit at 0 and at negative 2. And do you get, this is a y equals, if I say y equals, that's a quadratic, and it would have to go through those 2 points, so do you get it kind of goes like that? Do you remember that terminology of lead term? That's the lead term. And since it's positive in front, it's going up on the right. And since this is an even number, it's doing the same on the left. Well, let's figure out the right side first, and then you figure out if the left side is the same or different than that. Let me give you an example of that. You do not know what this looks like at all. Well, you know a little bit. Do you get that is a wave shape? It is not a parabola. Would you make a little sketch of it? Hint, you know the y-intercept. Hint, you know the right side is either going up or down. And then you can figure out if the left will be the same as that or different. See if you remember all of this. I'm going to ask you to, if you're having a little bit of trouble with this, which I get, I want you to figure out a few things. First, I want you to figure out the y-intercept, which is where, what's the y-intercept where? You can go back there and look. It's okay. The y-intercept is where what? Finish that sentence. X equals 0. You should be able to figure out the y-intercept pretty easy. Next, you should figure out the right side, and it's either up or down. And what tells you that? The lead coefficient, which is the number on the lead term. Okay? And then the left side is either the same or different. And hopefully you know where that comes from. I'll teach you that again in a second. Then, got y-intercept, right side, left side, and then last but not least, it'd be handy if I knew if there were any roots, but this one doesn't factor, so don't worry too much about what the roots are. If it would factor out for us, you know, then it would be great because I could tell what the roots are, but this one won't factor. All right, so then you should be able to just go like, okay, I think it goes like that, or something like that. All right, I'm going to pause for a second while you figure out the y-intercept, the right side, is up either or down. The left side is up or down. And then make a little sketch. All right, so y-intercept. Finish this sentence. The y-intercept is where x equals 0. If you didn't know that, you should write it down. Then the y-intercept is where x is 0. That cancels all that out. Now I ask again, what's the y-intercept? Y equals 7. So then 7, wherever that is, I can number by any, any amounts I want. I'll choose that. There, that's the y-intercept. Now how about this? How should the story end? Is she right side up or down? Prove it. Because the lead coefficient, which is the number on the lead term, is negative. You were saying it's going down here, and I agree. Okay. Now, at some point, it had to cross the x-axis. All right? Do I know? Can I have it all factored out? No. I can't tell where it crossed. Because otherwise, if this would have factored out and it would have come out to like, x minus 4 in one of the factors, I'd know, oh, it's crossing at 4, but I don't have it factored, so I don't know exactly where it crossed. But I do know it's going down on the right because it's negative. And I know it goes through 7. So can I just go like this? What's wrong with that? Prove that that is not right, TT. How do you know it has to go up on the left side? The right side was down. How do you know that's opposite of that? All right, because it's an odd, or not even, yep, therefore they are going to be different. If this is odd, the ends are going to be different. And so this can't be right. So I'm going to erase this, and I'm going to make it go like up. Now, has it got the y-intercept right? Yep. That was where x is 0, so it's 0, 7. Does it have the right side down? Check. Does it have the left side up? Check. And that's good enough then. I'm going to give you another one like that. See if you can do that. Y equals 6x to the 4th plus 3x squared minus 1. Make a sketch of this one based on everything you know. And then we're going to talk more about the factoring part, which will tell us the roots, the zeros, the x-intercepts. That's what we're really all about today. But I'm trying to remind you where we were before break, because I know you've been home for 4 days. Was it more than 4 days? 5 days. Wow. That's like half of a winter break. Not actually. Add 2 more days, and then add 7 days more after that. That's how awesome that's going to be in about 3 weeks. Aren't you guys doing fun things with the 2 weeks? Sometimes when we have 2-week breaks like that, we get more people doing fun things. Yes? Duluth. Awesome. That's a beautiful place. Let's see what I know about the Duluth in the winter. Lake Superior rarely freezes over, but it freezes out. Like it'll freeze out from the shore. And so people go ice fishing. I had a friend who went out ice fishing once, and the piece of ice that they were on broke off and then floated out. So now they're on Lake Superior in the middle of the winter on an iceberg, effectively, floating away from shore. Can you imagine how terrifying that would be? Because the scary thing is, what if your piece of ice flips over? Now you're in the water. Remember me telling you the cold water story? You only got 15 minutes. So that is actually a very dangerous situation. They got a helicopter to go out and pick them up. So anyway. All right. So don't go out on the ice. Just look at it. All right. So hopefully you knew. This one's got a 6 in front. Tell me. What do you know about that? So all I'm going to start with is the right side. So the right side will be up. I would agree. It's not telling me the left side. That is telling me the left side will be the same or different. Same. You are correct. It is up on both ends. And then it has to go through, Chloe? Correct, because that's the what? The Y-intercept. Is this possibly what the graph looks like? I know it's not likely, but is it possible? What do you think that tells you that it couldn't be that way? Yes? The Y-intercept is supposed to be -1. Now, could that possibly be the right graph? Now, I know it's not likely to be the right graph. Could it have some turns in it? How many turns could it have? Don't say 4. 3. It could have 3 turns in it. Does it have to have 3 turns? Nope, but it could. 1. No, wait, that's 1, 2 turns, 3 turns. See how I needed the 3rd turn to get going the right direction again? So it could have 3 turns. Okay. Now, I'm trying to show you how to find, there's 4 answers for this one. Look, see, it says 4. I'm trying to show you how to find those today by factoring. So what if we had to factor something like that? And that's what we're getting to now. We started with some baby factoring. Now let's move to some medium level factoring. Oh, I got a whole bunch of talking, which usually means that I did something wrong or there's some confusion. Can you tell me what you guys are talking about? It's okay. Go ahead. Okay. No, if it looks like this instead of the one I just did that was all wavy, there'd only be 2 real answers. But there has to be 4 answers. How is that possible? Well, it has to be 4 answers because the power's 4, but only 2 of them would be real and the other 2 would be imaginary. All right, so that's what I'm going to teach you in a minute. Yes?
How can you tell that it will have imaginary roots if you just look at the graph?
You can't tell unless you can factor it. So imagine for a moment that you got something factored and it looked like this. Let's make it a nicer number. And this. This one has 1 real root. If I set it equal to 0, it'll make it easier to see. The things that are the zeros are the x-intercepts. Do you get there's only 1 way to make this 0? If you make x what? Yeah. And I know some of you are thinking, but aren't there other answers? Nope. Those would take imaginary numbers. And so there aren't any other real x-intercepts. But how many answers are there supposed to be? What's the lead term? X to the 3rd. How would I get that? That times that. See how it's x to the 3rd if I multiplied it all out? Then do you get x to the 3rd should have 3 answers? But what you just said was only 1 answer. Only 1 real answer. But 2 imaginary answers. All right, let's see if you can handle this part. This x squared plus 4 here, that can be factored if you remember how to do it. I did it on just an extension day where I was like, you could do this, but you don't have to know it yet. But guess what? Now you have to know it, this chapter. So I pre-taught it. Let's see if any of you remember this. You go x and x. You go plus and minus. Anybody think they can do it? I know you're thinking, well, it can't be 2. Because then this would be positive 2 times negative 2 makes negative 4. And it's supposed to be positive 4. Yes? Yes. How did that happen? Where'd you pull that from? Because I times I will make I squared. And what's I squared equal to? -1. And that's going to bring us our extra negative. That's how you factor that kind. Whew! Hardcore factoring. Let's see if you can handle that on a different problem. X squared plus 16 and x minus 8. There's real roots and there's imaginary. Sometimes they just call them non-real. Would you tell me what the real roots and what the imaginary roots are? Hint, if you factor it the rest of the way, it'll just yell out the imaginary roots. Here's the real key right here. You already know it's x minus 8. That doesn't factor anymore. But this part does. We do factor it all the way and then compare yours with the person I pair you with. I'm going to pause for a second while I pair you with somebody. All right, x and x plus and minus 4 and 4. And why can't I stop right there? Because when I multiply that out, it would give me negative 16, and I want positive 16. So what do you have to throw in? An I. And therefore, my real answer was 8. Get how 8 would make this equation 0? And my imaginaries would be plus and minus 4i. You can write them separate, plus 4i, minus 4i, or you can put them together. All right? But now, let me show you something. What if the whole problem had started a little more complicated? What if the whole problem had been x to the third, and then I'm going to do my outside-inside thing, plus minus an 8x squared you get what I'm doing right now? Plus a 16x and minus a 16 times 8. Let me think. 8 times 10 is 80. 8 times 6 is 48. 128. Do you think you could have factored that? That's pretty hardcore factoring. We might not have one that difficult on the test, but you're going to have to factor things like this. Okay, so let me teach you how to factor things like that. You ready? I'll give you a baby one. X to the third plus 2x squared plus x. You know what? Make it 3x. I think you'll like it better. Plus 6. This kind of factoring, the new thing for the day basically, is something called factor by grouping, and I like to call it divide and conquer. If Alex the Great were asked, what's your favorite battle strategy? He would have said, it's awesome if you can divide the other guy's army into 2 parts and only fight half of it at a time. Do you get if your armies are about equal size, but you only have to fight half of his army because you have him distracted? Then you're going to have a massive advantage. Picture in World War II. There was a war between, a lot of countries, okay? But let's say we are obviously knowing that we were involved, the United States was involved, and the big player on the other side is the Nazis, okay, Germany. And so we are going against Germany, and we definitely had a lot of allies that were super important and couldn't have done it without them. But we were trying to land our troops in Europe, and do you remember what it was called, the big day? D-Day. Do you know that we successfully got Hitler's army divided into 2 parts? And we only had to land on that beach against half of his army? That was so smart, because if we had just parked all our guys over and making it obvious, they can fly over and see all of our guys in one spot, and it made it super obvious that we were going to land on that beach. They would have had every one of their big guns there. They would have had all their units there, and when we would have landed, they would have killed all our guys because they're so vulnerable running up onto the beach. Okay, we did sprinkle some paratroopers, but it's really hard to drop tons of people that way. Just a small number can drop in there in parachutes. Back and behind the lines, it's really dangerous stuff too. But anyways, we dropped all these guys on the beach. But thankfully, we had divided his army into 2 parts. And he had totally bought the fake to the north. We had faked that we were going to land on a beach way further north. How did we fake that? With cardboard or wooden tanks and tents. And everything was made of wood, except that what's one thing that's really hard to fake? People. And so we had a bunch of people milling around amongst these fake tanks and fake structures, and we completely fooled Hitler. He thought we were going north, so he had his best divisions way north of Normandy where we landed. Okay, if we hadn't done that, if we hadn't faked that to the north, he would have had all his guys there, and we wouldn't have made it up the beach. As it was, tons of guys got slaughtered on the way up the beach. But we faked, and we got his main army from that side of the country divided in half. And that's the reason we made it work. So if you can look it up, this fake was really, really effective. And his best divisions, some of his Panzer divisions, were some of his best ones, were up north because he was sure that's where we were going to really land. Because strategically, it would have been better in some ways for us to land up there. So he got sucked into that. All right. So anyway, trying to tell you, there's a reason to break this into two parts because then you only have to factor one thing at a time. If I just ask you to factor that part, I know you can do that. Go ahead, factor that part. Just that part. What goes into both of those things? X squared. So x squared comes out, and what's left? X plus 2. That wasn't that bad. You should have been able to do that. Okay, how about the other part? Mr. M, factor the second part for me. Take out a 3. I'm going to make it a plus 3, just because I don't want this to be hanging here without a sign. Okay, and then what comes in at the end? Excellent. Now, do you think it's coincidental that they both ended up with an x plus 2 here? No. Set it up on purpose so that would happen. So now that there's an x plus 2 in both parts, anybody think they can finish it? What do you think? I'm going to put that in front because normally the thing that factors out. Now, some of you are like, how did you do that? This and this are a common factor that can be factored out to the front. Now, the most common question I get if kids are bold enough to ask it is, but there was 2 of them. Why isn't it squared? And that's kind of a good question, but it's like this. Isn't there a 3 in both of these? So I pulled it out and put it in the front. Did I need a squared on it? No, because they would just get multiplied back in, and it makes the original. If you multiplied this all out again, you'd get this back. Get what I'm saying? I take this times the 2, and I'd get, wait a minute, I'm doing it backwards. Okay, I'd take this times the x squared, and I'd get this part. And I'd take this times the 3, and I get that part. All right. Why did we do all that work? Because then it equals 0, and I have found the roots, the zeros, the x-intercepts, the solutions. And they are x equals negative 2. And ew, that part is gross. But I can do it. Can you do it? Hint, if you factor it and use that little thing I just taught you, and you're going to be like, but it doesn't have a square root. So you're saying you don't know what the square root of 3 is, so use the square root of 3. This doesn't need to factor. This does. Use that I thing I just taught you a second ago. Intense. I for intense. This is some of the most hardcore factoring that you'll do all year, is in the next 2 weeks. And then we only have one more chapter, and then you're done for the semester. This chapter and one other chapter, and we're done for the semester. That puts us to the end of January. This chapter and one other chapter. Okay, did you catch that this was x and plus and minus? Just do one thing at a time. You can all do that. Then, but what's the number? And isn't there something with I? Oh, there's an I. There's an I in both of them. And this is how I'd want you to kind of think it out. And then go, because I times I is I squared. And then that makes this turn into actually negative I squared, which makes positive. Sweet. And then what could I multiply to make a 3? Say it. Come on, what should go here and here? You can do it. Square root of 3 and the square root of 3. Square root of 3 times the square root of 3 is 3. I know, that was tough, but that's what you're going to have to do. I just taught it to you today for the first time. Do you think I expect you to be the master of it instantaneously? No, but that's a typical question from the end of the unit. And the answers would say, what are the real roots? As in things that would cross the x-axis, the real ones. X equals what? Negative 2, because of this. And then these guys are the imaginary ones. So the imaginary roots, sometimes they call them the non-real roots. And they are, well, what could I put in here? Yes, but let's just say right here on that spot, right there, if I had a negative I root 3, it would cancel out the positive I root 3 and make it equal 0. And then the other one, positive I root 3. And so you're right, plus and minus I root 3. Wow. So the people that are gone today, hopefully they're watching that video. It's like Inception. You're watching the video at home and I'm talking to you. Yes, I mean you. Okay, so here's another one. Use divide and conquer to factor this all the way down, and then even do that fancy factoring with the I so that you'll have your imaginary roots. This is divide and conquer, just like we did to Hitler. Only have to factor the first part. And once you get done fighting that battle, all those guys that he had way up north, we still had to beat them, but at least we only had to go against half of his guys. On the way up the beach. Our coach, football coach, Nelson, Mr. Nelson's dad was one of the guys driving those crazy boat cars that would land the guys on the beach. And he drove guys up onto that beach. So he's really old now. It's like 90 something. But he comes on Veterans Day for our Veterans Day celebration. He's there for the last couple of years. So he was there that day. Made it out, obviously. There's not many World War II vets left. My dad was super young when he went in at the very end of the war. And even he was old when he died not that long ago. But if he was super young when he was in the war and he died, he would be 90 right now if he was still alive, approximately. You can imagine how old you have to be to still be alive if you were in that war. Okay, you should have got x squared to come out, and then you should have said x plus 3. You should have got negative 6 to come out. Did I fool some of you on that one? And then you get x plus 3. And if you were like, but these aren't matching, then you didn't take out negative 6. How many of you caught that and were able to factor that way? Okay, good. Then, Marin, finish it. Just the factoring first. Factor out this part. Maybe you don't know what to do. Do they both have an x plus 3 in them? So let's factor that out to the front and put it here. Okay, but I'm not going to put them both side by side. They go together in the front. Kind of like when we took a 6 out of this and this, we only put one of them in front. So those two to go together in this spot, and then we just have to put what's left. After I take out these guys, see what's left? And then, that's factored all the way, and that's all I asked you to do. But would you try and now factor it with those imaginaries? If you haven't already, or if you got stuck before, write it here, get it this far, and now try to factor this last two. Because if you can factor these, you're getting through some of the toughest stuff. I know I'm making today a little more difficult, but it'll be worth it, because at the end, you have to know how to do this. To get an A, you'd have to be able to do this part. But what if I don't know the square root of 6? Then just put the square root of 6. Yes. All right, so what do you think the answer is? I'm not saying you're wrong. I'm just saying what should I factor this to? And x minus square root of 6, and you are absolutely right. But wait a minute, Mr. Server. You said that there was an I here. If that was positive, do you get there would be an I? But since there's a negative here, I can just use a positive times a negative makes a negative. So you're right. I don't need imaginaries. In fact, that means I have 3 real roots. One of them's at x equals negative 3. One of them's at x equals negative square root of 6. And one of them's at x equals positive square root of 6. Those are my 3 real roots. There aren't any imaginaries. So on the test, on the imaginaries blank, you would have put none. There was no imaginaries. There's 3 reals. Okay, good catch. One last kind. Here, I'm going to give you a simple one first. Factor this one. Don't overthink it. It's just normal factoring. And that'll set you up for the big one. Do you see why I tried to get people to get good at factoring before this moment? Because now we're doing these crazy factorings that are like using square roots and imaginary numbers and divide and conquer and all that crazy stuff. That's why I asked you to work on the top 20 and the first 20. Get those down so that this moment could go so much easier. Okay, do you have an x and an x to make the x squared? Do you have a number here and here that multiplies to negative 4? So you use probably a 4 and a 1. Why? Because I want to make a 3. So how do I put in my 4 and my 1? I just put them in, and then I just guess on which one I think should be negative, do it quick in my head, and then see if I have to change the sign. All right, so I'm guessing that this one needs to be the positive and this one needs to be the negative. I check by doing that times that and that times that. I know some of you are like, but you can just see what they add to. If they add to 3, you're good. But when this changes to a number in front, that won't work anymore. My way of doing the outside and the inside is smarter in the long run because there might be a number here next time. And then you can't add them to that. Don't do the add to that trick. Not smart because it hurts you later. Okay, so did this actually work? Negative 1, positive 4 makes positive 3. Sweet, I'm done. It's got 2 real roots. One of them's 1, one of them's negative 4. Raise your hand if you got the same thing. Okay, good. Now, the big daddy. You're going to realize that this is a lot the same as what you just did a second ago. It's very, very similar. Don't think divide and conquer. Why? What are you going to divide that 3x squared like this? And if you did, what would factor out? Nothing. Even if I did this, then how are you going to leave a 2 at the end? That's not going to work. Divide and conquer will not work unless there's 4 parts. But just plain old-fashioned 2 parentheses factoring. Think about what goes here and here to make x to the 4th. Then figure out what goes here and here. That'll multiply to 2. There's not many things that you get to pick from, so that makes it pretty obvious. How many of you figured out it had to be x squared and x squared? Raise your hand if you had that figured out. Okay, good. Then, tell me what to do next, Miss S. What goes here and here? Plus 2 and plus 1. Awesome. Because 1 times 2 makes 2. Now, shouldn't I do just a little check and make sure I have it right? Yes. Especially check these. Do you get that makes x squared and 2x squared, which together makes 3x squared? Yay, I'm doing it right. Then you can do the hardest kind we've had yet. You can get 4 imaginary roots by doing this weird factoring with the eyes. The eyes have it. Okay. 12-minute warning. I'll have you in your homework momentarily. All right. Did you realize this was x and plus and minus? I hope you get that pattern. Whenever you have just 2 things like this, it's always going to go like that. And now you got to figure out what times what is going to make 2. No, not 2 and 1. They have to be exactly the same. Square root of 2 and square root of 2. Now, is that going to work though? I got a positive and a negative and it's making it positive. Nope. Got to throw in an extra what? What letter is missing? I. You need an I on each of them. And Miss Rhodes, what do you get for this last one? Nice. Keep going. I. Let me just simplify square root of 1 for a second. What is the square root of 1? 1. And do I really have to put a 1 on my I? There you go. That's it. Could I said square root of 1? Well, technically you're leaving something not simplified, so I wouldn't want you to leave square root of 1 on there. I'd have been okay with you putting a 1 here and a 1 here, but 1i just looks more complicated than just I. Okay, so what are the roots? Well, there's 4 of them. Negative I root 2, positive I root 2, negative I, positive I. There's 4 answers. Does that make sense? Yes, because there's a 4 there. Was there any real ones? No. That means it didn't have any x-intercepts. What? I thought the x-intercepts were the roots. Not if they're imaginary. You can't have imaginary x-intercepts. So this doesn't have any x-intercepts. Could this be the graph? It's to the 4th, so that both ends, oh wait, the lead term is x to the 4th, and there's a 1 in front, and it's positive, so it's going up on the right. It's got a y-intercept of 2, so I'd go through about 2, and then it would be going up on the left also. Yeah, that could be the answer, and it doesn't have any real roots. It's got imaginary ones, 4 of them. There, that's some challenging stuff. That is a typical homework question, and I want to start your worksheet with you right now. Everybody find the worksheet that's posted for today, and we'll start it together. Okay, this worksheet is due by midnight tonight. Just so you know, from now on, all my deadlines are going to be midnight of the day I assign it. I know for some of you that'll be frustrating, but you'll just have to shift around. And if you want to do other homework in the morning, don't do mine in the morning because the homework's going to always be due at midnight on the day I assign it. So I'm always making little changes like that to make it easier to post things and easier to get my gradebook lined up. So anyway, bottom line, this is due except for problem 7. You may skip problem 7, so everybody cross that one off. And I'm going to do a few of these with you right now. So get some free answers here and make sure you understand how to do this. So right off the bat, some of you guys are going to be like, I don't know how to factor that. Just make 2 sets of parentheses. How do I know that? Because there's 3 terms, so there's 2 sets of parentheses. Then just start thinking it through. What times what would make x to the 4th? Say it loud if you know it. X squared and x squared. Good. And then what times what would make 36? Now there is several choices, but we got to find a combo that would make negative 13. Would 6 and 6 make a 13? No. So what do you think of it? 9 and 4. Now, can either one of them just be negative or positive? No, it's very important what you choose for signs here. Do you get that together they got to make positive 36? So can I just put both of them as positive? No, because this term's got to be negative. So then that logically forces you to make both of them negative. How many of you already knew that and had it written down? Good. Then I can factor it further. You don't stop there. If you left it that way and called it factored form, I'd have to mark it wrong because you did not factor all the way. That was one of the things I marked wrong on your test a lot, is people didn't factor it all the way. This test, when it comes, that'll be the most frustrating thing is you'll go, oh, I can't believe I didn't factor it the rest of the way. Because you're so close when you get to that point. And it's just x plus 3 and x minus 3 and x plus 2 and x minus 2. This one's even pretty easy because there was no imaginaries. Since there was no imaginaries, however many roots there are is however many x-intercepts there are, because there weren't any imaginaries. Factored form, this answer goes there. The zeros, negative 3 is a 0, but don't just write negative 3, that's a bald answer. Negative 3, x equals negative 3, x equals 3, x equals negative 2, x equals 2. And number of x-intercepts, there's 4 of them. Cool, I'm done. This next kind, divide and conquer. The first 2 terms, that's easy. So true in life too. Just take one step at a time. You don't have to do it all at once. Sometimes you have so much stuff to do in front of you. Just do one thing at a time. And honestly, in my opinion, start with some easy things first. Because it gives you that feeling of momentum. Like, ooh, I'm getting this done. So x squared comes out. X plus 1 left. What also comes out of this other one? Negative 4 comes out. And what do you have left then? X plus 1. Then, since these are the same, they can get factored out. And when they're factored out, what's left? X squared minus 4. Kid writes that. I cry a little bit, take off 5%. Because they did all of that work, not for nothing, but they're going to lose, like, dang, their grade goes down from a straight A to an A minus. Because it wasn't factored all the way. Try not to be that kid. It's going to happen a lot, though. You won't get it factored all the way. You'll forget, oh, crap, I didn't factor it. One more step, and I would have had it. Was there any imaginaries here? Nope. That means all of these are x-intercepts. 2, negative 2, and negative 1. There's 3 of them. Factored form, that's this. Zeros, x equals. I would accept this 1, negative 2, and 2. If you're plus and minus 2, yeah, but not the 1. All right, and then this one. A lot of people get all messed up on this one, but it just, you got to notice something at the very beginning. Factor what? Nope, there isn't. Oh, wait a minute, you're right, you got me. I thought there was just an x. You're right, there's a 2x in everything. Good catch. Since there's a 2x in everything, that gets factored out. Leaving x squared plus 2x minus 15. Thank you. And then always look and see, could that be factored again? Yes, it can. Because 15 is 5 and a 3, and that can make it 2 with a 5 and a 3. Being careful with negatives and stuff. That should be able to be factored again. And don't forget your 2x. A lot of people go, but does that actually have an answer? Yeah, because that could equal 0. It might make it easier for you if I wrote 2x plus 0 and put a parenthesis around it, and make you realize, oh yeah, that could be equal to 0. And this could be equal to 0, and this could be equal to 0. Those are the 3 zeros. And we haven't had many that have that negative with the square roots and the i's. It's okay. I did the little pre-teaching there because I kept telling you on the final test, this is what you'll have to do. Well, today could have been a little easier if I hadn't taught you that, but now that makes tomorrow easier. And you're fully back in the swing. I don't know if you even noticed, but I skipped over the assignment that we would have had if we had had a snow day. Just gone. Letting it go. Because otherwise we'd have to double up. Because we need to stay on the same pace. Because that assignment was just a review day. And I built in a lot of review to today. And if I back us up a day and like go do that assignment for tonight's homework, either we'd have to do 2 assignments tonight, which is yuck, nobody wants to do that. Or it would put us behind a day, and our big test would happen the day you returned from break. The way it's scheduled right now, your big test happens the day before we go on break. And if any of you are like, oh crap, I'm leaving a day early for Christmas break because the airfares are cheaper, and I know, I get that. And I totally get if you need to leave, you're going to go. You're not going to like say, I got to stay for a math test, Dad. But if you do miss, if you're going to leave early, I would really look into taking the test after school the day before you leave. Know what I mean? Like you'll be all ready for the test. And if you're just going to leave that one day before break, that Friday, then take it Thursday night after school. All right, your assignment is all of this except problem 7. I did it up through number 3. That only leaves you like 4 questions. Get them done. Have a great day. 3 questions. 3.5.